In today's lesson, we're going to continue factoring ax squared plus bx plus c. So we're still looking at quadratic terms. We're still looking at trinomials. The only difference is today our leading coefficient can be anything. It can be 1, it can be prime, it can be composite. Now just recall, composite means that it has more factors than 1 in itself. So meaning like 4 has 1 and 4 and then 2 and 2. Our steps for factoring are also the same. You're going to start by factoring out the greatest common factor. And it's important that you remember this step, so you might want to highlight, star, underline, do something to call your attention to step 1, factor out the greatest common factor. Then you find your factor pairs for a and c. So remember, your a is the coefficient of x squared, and your c is typically the constant. Then you're going to guess and you're going to check until you find a combination that works. And you must check. Okay, it is very important that you constantly are checking your answers to see if they're correct. So let's jump down here to number 1. We're going to have 4x squared minus 15x minus 54. Now, we're going to check for a greatest common factor. So 4, 15, and 54 have no common factors other than 3. Now, you might think it has a 2 in common because 4 and 54 have a 2 in common, but 15 doesn't. Okay, so there is no greatest common factor. So the next step is to list all our factor pairs. So starting with 4, I have 1 times 4, and I have 2 times 2. And those are all my factor pairs for 4. Now, 54 has quite a few more. So we have 1 times 54, 2 times 27, 3 times 18, 4 doesn't go in, 5 doesn't go in, and 6 goes in 9 times, and then 7 doesn't go in, so I'm back to my turnaround point. Okay, so once I get there, I know I've got all my factors. So there's quite a lot of guessing and checking we have to do. So at this point, you might want to pick up a pencil because we're going to be doing a lot of erasing. So we're going to write down our 2 factor parentheses. Now, in the previous lessons, we knew there was only one possibility for our x squared term. It was either going to be x times x, or if there was a 3 in front, 1x times 3x. That's not the case here. 4x squared has 2 possibilities. So we're going to have to pick which one we want to start with. You can start with 1 and 4. You can start with 2 and 2. Typically, I start with the smallest factors. Doesn't always work, but that's where I typically start. So I'm going to plug in 2x times 2x. Now, the next thing I'm going to look at is my signs. So my signs here, because the second sign is negative, that means my signs are opposites. So I don't really know what my signs are at the moment. So again, I'm just going to plug them in, and I might have to erase them and change them. And now we need to pick a factor pair to start with for 54. Again, I typically start with the smallest. So I'm going to start with 6 and 9, and that's going to give me 12x minus 18x. Which is negative 6x. And even if I were to change the signs, that would just change the number. I need a 15 there, and I have a 6. If I were to flip-flop 6 and 9, it's not going to change it because 2x and 2x are the same. So 6 and 9 did not work for 2 times 2. So I'm going to erase 6 times 9, and I'm going to try a new factor pair. So maybe I'm going to try 3 times 18. Oops. So 3 times 2 is 6x, 2 times 18 is 36, and that's a negative, which gives me negative 30, and that definitely doesn't work. So as you can see, our numbers are getting kind of larger. I have a pretty strong suspicion that 2 and 27 aren't going to work, but I'll still try them just to make sure. So 4x, that's negative 54. Yep, that's negative 50. I need 15. So I'm just getting further and further away. And if I was to plug in this 54 in here, I'd end up with 100 and something. 108, I believe. So probably not going to work. So what this means is 2 times 2 is not a good factor pair, so that one doesn't work for 4. So this time, we're going to try 1 and 4. So 1x here, 4x here. Again, I'm going to start with my smallest, so maybe 6 and 9. So 6 times 4x is 24x. 1x times negative 9 is negative 9x, which is going to add up to 15x. So close. So I've got my number. The only thing wrong is my sign. So I'm going to erase my signs, and I'm going to flip-flop them. So now let's see. Negative 6 times 4 is negative 24x. 1x times positive 9 is positive 9. And that is going to add up to negative 15x. So I'm just going to double check. 1x times 4x is 4x squared. Check. Negative 24x, positive 9x is negative 15x. Check. And 6 times 9 is negative 54. Check. So my answer to this problem is x minus 6 times 4x plus 9. Okay, and you can put them in either order. 4x plus 9 times x minus 6 works just as well because of the commutative property. Now, I picked this first problem because it was a little frustrating that we had to try so many factor pairs. Sometimes you just have to guess and check until you find a pair that works. Okay, so it might be frustrating. Sometimes your first guess is going to be the right one. Sometimes it's going to take 6 or 7 guesses. You can't give up. Until you have exhausted every single option, you have to keep trying the factors. Okay, so now let's look at number 2. So number 2 is going to be 4x squared minus 4x minus 15. So again, our first step is to list all our factor pairs. So 4 is going to be 1 times 4 and 2 times 2. 15 is going to be 1 times 15 and 3 times 5. Now this one's already a little bit nicer because we don't have quite as many factor pairs for either number. So now we're going to draw our parentheses. Now of course you were first supposed to check for a greatest common factor. However, this does not have a greatest common factor. Alright, so plugging things in. Again, I like to start with my smallest numbers. Negative 4x is pretty small, so we may have to use small numbers. So I'm going to start with 2x times 2x. Again, I'm looking at my signs. They're going to be different. So I'm just going to plug in a plus here and a minus here. We might have to change them. And then I'm going to start with 3 times 5. So I'm just going to plug 3 here and 5 here and see what happens. So 3 times 2x is 6x. 2x times negative 5 is negative 10x. And look at that, it's negative 4x. So, first guess was the right one. Sometimes that happens. So let's double check and make sure we didn't make a mistake. 2x times 2x, 4x squared. 6x minus 10x equals negative 4x. And 3 times negative 5 equals negative 15. So we have the right answer here. So we have 2x plus 3 times 2x minus 5. So as you start to work with these more and more, you'll get quicker at guessing. You'll be able to kind of rule out the less obvious answers, and you'll be able to see that certain problems work better than others. Okay, so let's try number 3. So it's going to be 8x squared plus 59x minus 40. So let's start by writing our factor pairs. So 8 has 1 times 8 and 2 times 4. 40, 1 times 40, 2 times 20, 3 doesn't work, 4 times 10, 5 times 8, and I think we're good there. So what I want you to do is right now I want you to pause the video. I want you to see if you can figure out which factor pairs are going to work here in our parentheses. Have your eraser ready. You're going to have to probably guess and check a couple different pairs. And then when you're ready to check your answer, turn the video back on. Alright, so probably had to go through quite a few guesses here because 2 and 4 were the ones I started with and they didn't work. So I had to use 1 and 8, 1x and 8x, and then luckily it was the first guess after that, 5 and 8. That gave me 64x minus 5x, which is positive 59x. So this would factor into x plus 8 times 8x minus 5. So if you got this one correct, give yourself a smiley face. If you didn't get it correct, put a little frowny face in. Remember, part of this is just trying hard, being consistent. Don't quit guessing until you find an answer. Everything I'm giving you at this moment is going to factor. All right, number 4. I'm going to have 10x squared plus 19x plus 6. So go ahead and pause the video. I want you to try this entire problem on your own, and when you're ready, turn the video back on. So one nice thing about this problem is you know your signs. You don't have to guess and check your signs. They're both going to be positive. So when I check my first factors, 2x and 5x, I know for sure there's pluses in the middle. Okay, so now 2 and 3, if I put a 2 here, that's 10, and a 3 here is 16. So sometimes I do my mental calculations. So I'm going to actually reverse that and put a 3 here and a 2 here, which is going to give me 15x times, or plus, sorry, 4x, which adds up to 19x. So you should have gotten that your factors are going to be 2x plus 3 times 5x plus 2. So again, if you got this one correct, give yourself a little smiley face. If you got it wrong, put a little frowny face. And if you have any questions, write them down so you remember to ask me about them tomorrow. All right, let's look at number 5. 9x squared minus 24x plus 12. Now, you're always supposed to check for a greatest common factor, and this is no exception. So the first thing we're going to do is we're going to see, is there anything in common? And right off the bat, I notice that I can take a 3 out of each of those. So we're going to factor a 3 out. So it's going to give me 3x squared minus 8x plus 4. Now, this is important for a couple of reasons. First of all, it's going to make the factoring of the trinomial a lot simpler. So I went from having 4 factors for 9, 1 and 9 and 3 and 3, down to having 2 factors for 3, 1 and 3. So there's not near as much guessing here. Same thing with my 12. I had 3 sets of factors, 1 and 12, 2 and 6, 3 and 4. Now I only have 2 sets, 1 and 4 and 2 and 2. So it cuts my time down a lot. And then secondly, in order to be factored completely, which is what the instructions say up here, we are factoring completely, you have to take out all the common factors, which means the greatest common factor has to be out in the front. So now we're going to take a look at 3, which is, like I said, 1 and 3. And 4 is 1 times 4 and 2 times 2. And we're going to bring down our 3. So he's going to hang around for a little bit. Okay, and we're going to draw our factors for just the expression 3x squared minus 8x plus 4. So that's the only thing that's going to go into our 2 binomials. Now, the good thing is we know it's got to be 3x and x. So this is hearkening back to the previous lesson when we had a prime number in front of x squared. Now, we also know that both of our signs are going to be negative because this is positive, which means they're both the same sign, and they're both negative. So I'm already liking this problem a lot because I don't have too much guessing to do, and I've only got to guess between 1 and 4 and 2 and 2. So of course I'm going to start with 2. So that's going to give me negative 2x, and this is going to give me negative 6x, and look at that, negative 8x, it fits beautifully. I'm done. Always going to check, of course. 3x times x is 3x squared. Check. That did definitely add up to negative 8x, and negative 2 times negative 2 is 4. And then if I was to remultiply this back out, 3 times 3x squared is 9x squared. 3 times negative 8x is negative 24x squared. And 3 times 4 is positive 12. So I am 100% sure this is correct. So 3 times 3x minus 2 times x minus 2. Now you might ask, well, what if I hadn't seen that greatest common factor? What would the problem have looked like? So don't write this down. I'm gonna show you down here in box 7. If you had forgotten to factor out the greatest common factor, you could have gotten two possibilities. You could have gotten 9x minus 6 times x minus 2, or you could have gotten 3x minus 2 times 3x minus 6. Okay, so immediately I know this is not very good because I can see that this right here, this first factor has 9 and 6, which has a greatest common factor. So if you end up factoring by mistake and don't remember to take out the greatest common factor at the beginning, you can always take it out here at the end. The problem with that is a lot of students forget to take it out at the end. So always double check your factors. Notice here on 3x minus 2 and x minus 2 on my original answer right here, it's right here, 3x and 2 don't have anything in common. X and 2 have nothing in common. Whereas here, 9x and 6 have a 3 in common, which means they could factor out a 3 and get 3x minus 2 times x minus 2. Likewise, on the second possibility, 3x minus 6 has a 3 in common, which means you could take a 3 out and you'd have x minus 2, and then you'd have this 3x minus 2 in front, and you'd have to rearrange so that 3 was in the front. Okay, so it is possible to factor out the greatest common factor at the end. It's just not always advisable because you may forget about it. Okay, so GCF first, make your life a little bit happier. All right, so number 6. We're going to have 8x cubed minus 14x squared plus 6x. Now, right off the bat, you're probably thinking, wait a second. You said we were only factoring quadratics and trinomials. Well, this is a trinomial, but it's not a quadratic. It's actually a cubic. But if you look for your greatest common factor, you can easily see that each of these terms has an x in common. So that means we have a greatest common factor of x. Now, I'm still going to look at my 8, my 14, and my 6 to see if they have a common factor. And again, they do. 8, 14, and 6 are all even. So my greatest common factor is actually going to be 2x. So left over, I'm going to have 4x squared minus 7x plus 3. So again, we want to factor out that greatest common factor because it's going to make things a little bit easier. So we're going to bring down our 2x to hang around while we factor out what's inside our parenthesis here. So I like this problem, and I don't know if you noticed this or not, but 3, my C, only has one possibility for my factors. That's nice. That means I don't have to guess. I know they're 1 and 3. Now my 4 has 1 times 4 and 2 times 2. So we're going to have to do a little more guessing. So I'm going to start by plugging in 2x and 2x. Now another thing nice about this problem is we know my signs are both going to be negative. So no guessing there. And then I'm just going to plug in 1 and 3, see what happens. So this is negative 2x. This is negative 6x. Not quite. That's negative 8x. And I need negative 7. I can't be close. I have to be right on. So if I were to switch 1 and 3, it's not going to change the value because the first terms are 2. So that means I'm going to have to try to use 1 and 4. So 2 and 2 didn't work. I'm going to mark them out. Get rid of the 2's here. So if I plug a 1 here and a 4 here, that's going to give me negative 4x and negative 3x, which, look at there, negative 7x. Now, if that hadn't worked, I would have tried flip-flopping the 4 and the 1 and seeing if it worked then. But it wouldn't have. That would have been 12x and 1x, which is negative 13. So we have our answer. We're going to rewrite it as 2x times x minus 1 times 4x minus 3. Do a quick double check. No greatest common factors that I missed here. X minus 1, nothing in common. 4x minus 3, nothing in common. And of course, double check to see x times 4x is 4x squared. Negative 1 times negative 3 is positive 3, and our middles match up. So I want you all to try number 7. So number 7 is going to be 2x squared plus 22x plus 60. So go ahead and pause the video, and when you're ready to check your answer, turn it back on. Alright, so first off, notice if you had forgotten to take out the greatest common factor of 2, look at how many factors you have to check. 6 different possibilities. That's so much work. By removing out the 2 out of each term, we've now dropped our possibilities down to 4. And we've given ourselves an x squared with a coefficient of 1, which makes the problem even easier because I can easily see that 5 plus 6 is going to give me 11. So make sure you're finding the greatest common factor, and this is going to be your answer. So if you got this one correct, give yourself a smiley face. If not, give yourself a frowny face and write down any questions you have. All right, number 8. We're going to do 8x cubed. I don't think we did do this one. So let's actually do negative 6x squared plus 11x plus 2. So first step, greatest common factor. Remember, in the previous videos you've seen, we cannot have a leading coefficient with a negative number in front. So we have to factor out that negative. So while I'm factoring out the negative, let's see, do we have any other greatest common factors? 6, 11, and 2. Nothing else in common. So we're going to rewrite the new polynomial. That gives us a positive 6x squared, a negative 11x, and a negative 2. You must write this step. So now we need our factors. So 6 is 1 times 6 and 2 times 3. 2 is 1 times 2. So good news is we definitely have one set of factors. We know that we're going to have a 1 and 2 there. There's no other possible combinations. We also know we're going to have plus and minus, so I'm just going to throw them in somewhere. And now we have to decide, do we want to start with 2 and 3 or 1 and 6? So if we start with 2x and 3x, that's going to be 3x minus 4x, which doesn't work. So I'm going to flip-flop my 2 and my 3. I'm going to bring the 3 here and the 2 here. So that's going to give me 2x minus 6, which again, not cutting it. So we've exhausted 2 and 3. It does not work. So 1 and 6 have to be the correct combinations. Now, because 1 and 6 have to be the combination here, I'm going to kind of look ahead. I need an 11. So if I did 6 times 2, that would get me a 12. So I'm going to try putting my 6 here and my 1 here. So 1 times 1 is 1x. 6 times 2 is negative 12x. And that gives me my negative 11x. And notice when I'm checking this off, I'm checking at the beginning. 6x times x is 6x squared. 1x minus 12x right here. I'm checking this middle part because that's the polynomial I'm now factoring. And then 1 times negative 2 is negative 2. So my polynomial here checks out, and if you were to multiply the negative back, you would get the original answer. Okay, so our answer is going to be negative 6x plus 1 times x minus 2. Okay, so now what I'm going to do is I'm going to give you 2 polynomials to try on your own. I'm not going to give you the answer to these, so I'm going to give you the problem. You need to factor them, and then we'll go over the answers tomorrow. So number 9 is going to be 9x squared plus 38x plus 8. And number 10 is going to be 6x squared minus 19x minus 7.